right, so now we're going to do scenario summary. So for this one, this will be our scenario. We're going to be changing the first year price and variable cost based on these scenarios. So worst case is 125,000, base is 200,000, and best is 275,000 for the first year catfish sales. The price per pound is 2.25 worst case, base case 2.5, and best case 2.65. And then variable cost is percentage. Worst case is 65%, base is 60%, and then best is 55%. So now we'll go to data, what if, scenario manager. And we'll add our first one. So this is worst case, and then our changing sales, these here. Click OK for that. So then for this first one, B8 will be equal to 125,000, 2.25, and 0.65. And then click Add. Next one would be base case. All those stay the same. Click Add. And then best case, click OK. That's fine. And then now 275,000, 2.65, and 0.55. And we'll click OK. Summary, and we want the output cell to be the NPV. Click OK. And then you see these results here. So now I'm going to delete the current values because that's copied, and then play around in this sheet. So a couple things we're going to calculate will be the following. We're going to have probabilities to help us calculate the expected NPV. We'll do variance, standard deviation, and then the probability, assuming a normal distribution, that NPV is less than or equal to 0. So doing the calculation, and then we'll do a sum. So 20%, 60%, and 20%. So 60% best base case, 20% worst, 20% best. To get the expected NPV, that'll be sum. And then I'll highlight these NPVs multiplied by these probabilities. You get 158,213.33. The variance for this, we're going to use a FAME function. So FAME underscore variance, it'll be D10 to F10, comma, D15 to F15. We'll do another FAME function for the standard deviation. And we'll highlight those numbers again. So D10 to D10 to F10, D15 to F15. And then lastly, the probability that our NPV is less than or equal to 0. So this is going to be equal to norm.s.dist parentheses 0 minus D16 in that parentheses divided by D18, comma, true. So we want the CDF of this. And you see we get the probability of a negative NPV is 25.45%, making a lot of assumptions here. Okay. Next, we'll run a simulation to see what that probability would look like.